Hi, everyone. So we are going to look at exercise 1.7, number 6B, which is part of the homework. And the question says the given lines L1 and L2 intersect in a single point A, and find an equation for the line through A that is perpendicular to both L1 and L2. And then you are given equations of the lines L1 and L2. So what we need to think about is, okay, so what we need is to find the line that passes through A and is perpendicular to both. So we know that for us to be able to find the equation of a line, what we need is to be able to say, maybe let me write this in red, X is going to be equal to, because we are told it passes through A, so we do have a point already. And then what we need is to find some direction vector, so some t times, in this case, I will call it v, where v is the direction vector of the line, right? So we need that information to be able to find the equation or an equation for this line. So how do we do that? Okay, so the first thing is to find A. Why? Because we are told that L1 and L2 intersect in a single point A, so we are able to use what we already know about these two lines to be able to find A. So what do we say? So we know that A is in the intersection of L1 and L2. So what does that mean? That means that A can be written as 1 minus t, and 2t there, right? That's what it means to be in L1. And we should be able to write it in terms of an equation in L2. So that means that we are going to have 3 minus s, 2t minus, 2s minus 2, and then s minus 4, right? So here, so we can then say this is for some s and t, right? Some scalars s and t. And so here notice that I use a different parameter for L2 simply because we don't want that to mess up our calculations. It doesn't mean that t from L1 will be the same as the parameter for L2, right? So that's why we have got to have them different. And so we want to find S and T and then conclude or find A, right? So how do we do that? So because these are equal, we know that two vectors are equal if the components, the corresponding components are equal. So we say 1 minus T should be equal to 3 minus S. T should be equal to 2S minus 2. And then 2t will be equal to s minus 4. You can call this 1, 2, 1, 2, and 3. Right, and then we solve for s and t. You can use whichever you're comfortable with, but I can say from 2 and 3, I can see that t is equal to 2s minus 2. So I can put, I can plug in I can substitute t for 2s minus 2 in the third equation. So I'm going to have 2 times 2s minus 2, which is equal to s minus 4. And from there, I can simplify. I'm not going to do the calculation. It will be 4s minus 4 is equal to s minus 4. So therefore, 3s is equal to 0. So therefore, we get that s is equal to 0. And if I use my second equation, so from 2, I can then say that t is equal to minus 2, right? Because t will be equal to 2 times 0 minus 2, which is minus 2. And then I can verify if this is true or not by looking at one. Notice that I used 2 and 3 only here, so I can verify by I can check using 1. So I've got 1 minus 2, which is 1 plus 2, which is equal to 3, which is equal to 3 minus 0, which is all true. So from 1, we can see that that is correct. So therefore, we've got our S and T. So we can then substitute to get our A. So if I use my S is equal to 0, I get 3, 2S minus 2, which is minus 2, and then minus 4. So this is the point of intersection. So I've found one component that I need, which is A. Now I want to be able to find V, the direction vector, right? To be able to then write an equation for L. I'm just going to call it L3. So this would be L3, which is such that its equation is like that. So now I want to find V. And in the question, I am told that this line is perpendicular to both lines L1 and L2. So if I think of the direction of L1 and of L3, then it should be perpendicular to L1 and L2. So the question is, do we have anything that talks about that type of scenario where you've got two lines, and then you can find the third line, or at least the third vector, direction vector, that will be perpendicular to both the lines? And we do, and this is theorem 1.7.10. I didn't write what it actually says, but I wrote the illustration that is on page 51. And so what it basically says is, if I've got two lines, L1 and L2, so I've got my L1 going in that direction, L2 going in that direction. And then if I take a ray, because remember that both lines pass through A, right? And obviously L3 also passes through A. So all of them have got A in common, the three lines. So what I want is to be able to find this line, or at least this direction, such that both L1 and L2 will be perpendicular to that direction. So I've just written an illustration here. So theorem 1.7.10 tells us that if you've got a ray, so if you've got this ray like that, and then that ray like that, then if you take the cross product of the direction vector, so U and V here in this case, then whatever the cross product is going to be perpendicular to both these rays. So here I'm just talking of rays starting at A, right? We are talking of lines, but really we can just restrict ourselves to rays that are moving from there to from A to going in that direction, and then from A to that direction. And then for L3, we can also think of it as a ray, right? And that is moving from there to there, but really we will need the whole line when we are answering the question. So the theorem tells us that if I find the cross product, then of the direction vectors of L1 and L2, or of those rays, the corresponding rays, then I have got what I need, which is the direction vector of L3 in this case, because it will be perpendicular to both ray 1 and ray 2, right? So from there, so what I need to do is to rewrite my L1 and L2 such that I'm able to to see what is the direction vector for L1 and L2 respectively, right? So if I do that, I will see that L1 is such that we write an equation as 1, 0, 0 plus t minus 1, 1, and 2. And then for L2, I do the same. And then I've got 3 minus 2 minus 4 plus s times or t, whichever parameter you would have used. So this will be the line. So basically what I have is these are the direction vectors for L1 and L2. So what I need is to find the cross product of these. So therefore, minus 1, 1, 2 will be equal to, oh, sorry, the cross product will be like this, and this is equal to, so I'm not going to spend some time. I'm sure you've gotten some good methods from Dr. Messerschmidt and Dr. Schwanke on how to do a cross product. So therefore we get this to be equal to minus 3, minus 1, minus 1. So in other words, now I can say that my L3 is going to be equal to the equation is going to be equal to x is equal to a plus t times this vector here, minus 3, minus 1, minus 1. And I know what is a. It's 3 minus 2 minus 4, so I can write it is 3 minus 2 minus 4 plus t times minus 3 minus 1 minus 1. And that will be an equation of line L3. Here you can take out the minus and then write this as S3 minus 1 minus 1, or T, sorry. What am I saying? I'm saying you can take out the minus and then you're going to have something like this. It's still fine. It's not a problem. It will be the same. So you can replace this with that. But otherwise, this would be a good answer for this question. And that is it. Thank you.